Michio Kaku sheds light on a startling discovery. The James Webb Telescope has detected an alarming signal emitting from the Andromeda galaxy. For over a century, our understanding of Andromeda was largely earthbound. However, now, equipped with the James Webb Space Telescope, our perspectives are dramatically shifting. This recent data has sent shockwaves through the scientific community. But what does this shocking discovery tell us, and why is it causing such a stir among astronomers? Join us as we dive into the details of this revelation and explore what it means for our understanding of our neighboring galaxy. Before we delve into the details of the alarming signal, it's important to understand some context about the Andromeda galaxy. Historically, the Andromeda galaxy was the first clue that our universe extends beyond the Milky Way. This revelation shifted our perception, highlighting that we might just be a small part of a vast universe. Initially, the Milky Way was seen as the entirety of the universe. Early astronomers, using limited technology, could not separate the Milky Way into individual stars. This changed with Galileo Galilei. In the 17th century, using a telescope, he discovered that the Milky Way was made up of numerous stars. This finding began to challenge the idea that the Milky Way was the universe's only galaxy. The real game-changer came with Edwin Hubble in the 1920s. Using the Hooker telescope, he observed distant objects beyond the Milky Way. He identified these as separate galaxies, expanding our view of the universe. One of these galaxies was Andromeda, also known as M31. Its observation dates back to the Persian astronomer Abd Al-Rahman al-Sufi in the 10th century, who noted it without the aid of telescopic technology. By the 20th century, technological advancements allowed astronomers to explore further. They understood that Andromeda was a nebulous cloud with a vast galaxy of stars, similar to our own Milky Way, but located about 2.537 million light-years away. The study of Andromeda has evolved significantly since then. Observations have moved from ground-based telescopes to space observatories like the Hubble and now the James Webb Space Telescope. Each new tool has brought us closer to understanding Andromeda's true nature. Understanding Andromeda's structure and composition helps astronomers learn more about the universe. It serves as a comparison point to our Milky Way, offering insights into galaxy formation and evolution. The relationship between the two galaxies is crucial for understanding the future of our own galaxy, especially since they are expected to collide in about 4 billion years. Recently, the James Webb Telescope has received an alarming signal from the Andromeda galaxy. But what does the latest signal tell us? The James Webb Telescope has brought new insights. This advanced instrument, far superior to its predecessors, has captured data from Andromeda that challenges previous understandings. The telescope's powerful sensors have detected unusual activity in Andromeda's core, differing significantly from past observations. This has intrigued scientists globally. The signal suggests vital processes are occurring within the galaxy, possibly related to its supermassive black hole or previously unseen phenomena. One key finding is the variance in Andromeda's mass. Earlier estimates placed Andromeda as significantly larger than the Milky Way. However, new data suggest this gap may not be as vast as previously thought. Updated measurements indicate Andromeda and the Milky Way are more comparable in size, reshaping our understanding of our own galaxy's place. Additionally, the James Webb Telescope has provided clearer images and spectra from Andromeda. These have revealed new star formations and chemical compositions within the galaxy. Such details are crucial for understanding how galaxies evolve and what conditions might lead to life. Another significant discovery involves Andromeda's active galactic nucleus. The data indicates that the black hole at the center is more active than previously believed. This activity impacts the surrounding region and may influence the galaxy's overall structure and future. The telescope's findings also touch on the mysterious dark matter. By analyzing the gravitational effects on Andromeda's stars, researchers can better understand how dark matter is distributed throughout the galaxy. This is key to solving one of astronomy's biggest puzzles: what is dark matter, and how does it affect the universe? These recent discoveries by the James Webb Telescope have led to numerous studies. Scientists worldwide are examining the data to uncover more about Andromeda's secrets. Each finding helps piece together the galaxy's history and future, providing a clearer understanding of the universe's workings. Andromeda, our closest galactic neighbor, hosts a variety of unique features that intrigue astronomers and set it apart from other galaxies. Firstly, Andromeda's size is noteworthy. While estimates have varied, recent data suggest it spans approximately 220,000 light-years in diameter. This makes it one of the largest galaxies in the local group, significantly larger than the Milky Way. Its vast size contributes to its mass, holding an estimated 1 trillion stars, surpassing the number in our own galaxy. Andromeda's structure is another point of interest. It has a typical spiral shape, but with a twist. The galaxy contains a bulging center and a dense nucleus surrounded by rings of dust and gas, which are sites of active star formation. These features indicate a vibrant galaxy with ongoing processes that shape its appearance and evolution. The nucleus of Andromeda is particularly fascinating due to the presence of a double-peaked emission, suggesting it may harbor a supermassive black hole. This is similar to the Milky Way, but the nature and activity level of Andromeda's black hole provide crucial data for understanding these space objects. Moreover, Andromeda is surrounded by a halo of stellar material, extending hundreds of thousands of light-years. This halo is composed of stars, planetary nebulae, and globular clusters, providing evidence of the galaxy's complex formation and history. The globular clusters, in particular, are of significant interest. With over 460 identified, they offer insights into the early stages of the galaxy's development and the dynamics of star clusters. Another unique aspect of Andromeda is its satellite galaxies. More than 20 smaller galaxies orbit Andromeda, some of which are being tidally stripped of their stars and gas, contributing to Andromeda's growth. This process, known as galactic cannibalism, highlights the aggressive nature of galaxy evolution and provides a live example of how galaxies expand and interact over time. But how is the Andromeda galaxy changing, and what does its future hold? The transformation and future of the Andromeda galaxy are subjects of significant interest and research in astronomy. One major aspect of Andromeda's transformation is its potential evolution from a spiral to a ring galaxy. Observations suggest changes in its structure that could lead to this rare form. Ring galaxies are unique and form under specific conditions, often after a collision or near miss with another galaxy. If Andromeda is evolving into this structure, it indicates a history involving interactions with other galaxies. Andromeda's future is closely tied to its interaction with the Milky Way. Calculations predict that in about 4 billion years, Andromeda and the Milky Way will collide and merge. This event, while seemingly catastrophic, is a natural part of galactic evolution. The collision will not involve direct impacts between stars due to the vast distances between them. However, the gravitational forces will dramatically reshape both galaxies. During the merger, gas and dust from both galaxies will interact, leading to new waves of star formation. This burst of stellar creation will light up the merging galaxies, creating a unique and spectacular universal event. The collision will eventually result in a single elliptical galaxy, a process common in the universe's history but unique in human terms because of our direct involvement. The supermassive black holes at the centers of both galaxies are also expected to merge. This event could result in significant emissions of radiation as matter is consumed by the newly formed black hole. Studying this process provides insights into the life cycles of galaxies and the role of black holes in their evolution. So, what does the future of Andromeda and its potential merger with the Milky Way mean for the fate of our solar system? While it is unlikely that the solar system will be destroyed, its position and conditions could significantly change. This includes possible shifts in orbit or even ejection from the newly formed galaxy. Understanding these processes helps scientists predict the outcomes of similar events elsewhere and provides context for the eventual fate of our own galaxy. The study of Andromeda's transformation and future is about understanding the forces at play and the inevitable evolution of galaxies over billions of years. The anticipated merger between our galaxy and Andromeda raises significant questions about its impact on Earth's environment. Firstly, it's essential to understand that the vast distances between stars mean that actual star-on-star collisions are unlikely. However, the gravitational effects of such a merger would be profound. The merger could disrupt the stable orbits of stars and potentially send a number of them, including our Sun, into new trajectories. This change in position could have significant implications for Earth's climate. If Earth's distance from the Sun changes significantly, it could either warm up or cool down, depending on the direction of the change. A warmer climate could lead to melting ice caps and rising sea levels, whereas a cooler climate might trigger a new ice age. Moreover, the merger could lead to increased radiation reaching Earth. As the Milky Way and Andromeda's black holes come closer, their interactions could accelerate particles to high energies, increasing the amount of cosmic radiation penetrating Earth's atmosphere. This increase in radiation could have harmful effects on Earth's ecosystems, potentially leading to increased mutation rates in organisms and impacting biodiversity. Changes in Earth's orbit or axis could also disrupt the distribution of habitats across the globe. Species that are adapted to specific climate zones might find their habitats unsuitable, leading to shifts in biodiversity and ecosystem structures. Some species might thrive under these new conditions, while others could face extinction. Additionally, the merger might trigger new star formation as gas clouds from the two galaxies collide and compress. If this star formation occurs near the solar system, the radiation from these new stars could also affect Earth's environment, further influencing climate and life. However, it is important to note that these events are projected to occur billions of years in the future. Human life, as we know it, may have evolved significantly by then, or our species might inhabit different parts of the galaxy or universe. The findings from the Andromeda galaxy have significant implications for understanding our own galaxy and its future. The comparison between Andromeda and the Milky Way helps astronomers better understand the structure and evolution of spiral galaxies. Observing Andromeda's features, such as its spiral arms and the activity around its supermassive black hole, provides a reference point for studying similar characteristics within the Milky Way. This comparative study helps refine our models of galactic dynamics and evolution. Additionally, the discovery of Andromeda's size and mass has direct implications for our understanding of the Milky Way. Initial assumptions placed Andromeda as significantly larger than the Milky Way. However, recent data suggest that both galaxies might be more closely matched in size, reshaping our understanding of our own galaxy's place in the universe. Recent data from the James Webb Telescope suggests that the Andromeda galaxy may be similar in size to the Milky Way than previously thought. This challenges our perspective on the Milky Way's position in the local group of galaxies and its gravitational influence. Although the Milky Way is currently a barred spiral galaxy, interactions with neighboring galaxies, especially Andromeda, could alter its structure. Understanding Andromeda's transformation provides clues about the events that lead to such significant changes in galaxy morphology. By studying Andromeda's current state and predicting its future trajectory, astronomers can simulate the collision's effects on the Milky Way. This includes changes in star formation, the distribution of gas and dust, and the dynamics of both galactic cores. The field of astronomy has experienced significant changes, thanks to technological advances. From the earliest telescopes to the sophisticated observatories of today, each step forward has expanded our understanding of space. The journey began with the invention of the telescope in the early 17th century. This simple device, consisting of lenses within a tube, allowed astronomers to observe the moons of Jupiter and the phases of Venus. As time progressed, so did the complexity and power of telescopes. The 19th and early 20th centuries saw the development of larger, more powerful telescopes. These allowed astronomers to see further into space and to discover new celestial bodies such as Neptune. However, these ground-based telescopes had limitations, mostly due to atmospheric interference and light pollution. The launch of the Hubble Space Telescope in 1990 marked a significant leap forward. Positioned above Earth's atmosphere, Hubble provided clearer, deeper views of the universe than ever before. Its observations have led to breakthroughs in our understanding of black holes, the age of the universe, and the expansion of space. Following Hubble, other space telescopes, including Chandra X-ray Observatory and the Spitzer Space Telescope, have observed the universe in different wavelengths. This has allowed astronomers to explore aspects of the universe that are invisible to the naked eye, such as space dust and black hole emissions. The most recent advancements include the James Webb Space Telescope. Launched in 2021, the James Webb Space Telescope is the most powerful space telescope ever built. With its sophisticated instruments, it can observe high-redshift objects that are too old, distant, or faint for Hubble. This capability is crucial for studying the early universe, the formation of stars and galaxies, and the potential for life on other planets. On the ground, new technologies have led to the development of extremely large telescopes, such as the European Extremely Large Telescope and the Giant Magellan Telescope. These observatories, equipped with adaptive optics, can compensate for atmospheric distortions, providing images as sharp as those from space. In addition to optical telescopes, radio, infrared, and X-ray observatories have broadened our astronomical toolkit. These instruments allow astronomers to detect and study phenomena such as the universe's microwave background radiation, star formation regions, and the remnants of supernova explosions. Dark matter remains one of the universe's biggest mysteries, invisible yet constituting a significant portion of a galaxy's mass. Dark matter does not emit, absorb, or reflect light, making it undetectable by conventional means. Instead, its presence is gathered from gravitational effects on visible matter, radiation, and the large-scale structure of the universe. In Andromeda, evidence for dark matter comes from the galaxy's rotational speed. Stars near the galaxy's edge rotate at similar speeds to those near the center, contrary to what would be expected if only visible matter were present. This uniform rotation rate suggests a substantial amount of unseen mass, attributed to dark matter, enveloping and influencing the galaxy. Observations of Andromeda also reveal a massive halo of dark matter extending far beyond the visible stars. This halo influences the motion of satellite galaxies and star clusters orbiting Andromeda. By studying these orbital motions, astronomers can estimate the mass and distribution of dark matter within the galaxy. Such studies indicate that Andromeda's dark matter halo is both massive and extensive, extending over 1 million light-years from its center. The distribution of dark matter in Andromeda is not uniform. It is denser near the galaxy's core and becomes less dense outward. This distribution affects the formation and evolution of stars and gas clouds within the galaxy. Dark matter's gravitational pull helps shape the spiral arms and influences the rate and location of new star formation. Moreover, dark matter is believed to play a significant role in galactic collisions and mergers. The anticipated collision between Andromeda and the Milky Way, for instance, is also an interaction of the immense dark matter halo surrounding both galaxies. The dynamics of this collision, including the eventual shape of the merged galaxy, will be significantly influenced by dark matter. The recent discoveries from the Andromeda galaxy have significant implications for our understanding of the universe. Andromeda's findings provide critical data on galaxy formation and evolution. By observing Andromeda's structure, astronomers gain insights into how galaxies develop over billions of years. This includes the formation of spiral arms, the growth of central bulges, and the role of collisions and mergers in shaping galaxies. Understanding these processes in Andromeda helps cosmologists develop more accurate models of galactic evolution applicable across the universe. Andromeda's findings contribute to the calibration of space's distance ladder. By measuring distances within Andromeda and comparing them with those from other galaxies, astronomers refine the methods used to determine cosmic scales. This is crucial for measuring the expansion rate of the universe, a fundamental parameter in cosmology known as the Hubble constant. Moreover, the study of Andromeda's stellar population and chemical composition offers insights into the life cycles of stars and the distribution of elements across the universe. These findings help cosmologists understand the processes of nucleosynthesis and chemical enrichment that occurred in the early universe and continue to occur within galaxies. Discoveries about the Andromeda galaxy have played a significant role in creating public interest and enhancing science education. The exploration of Andromeda serves as an excellent tool for engaging the public with the wonders of the universe. Fascinating images and data from the galaxy provide a tangible connection to distant phenomena, inspiring curiosity and wonder. Public lectures, planetarium shows, and media coverage of Andromeda's findings attract people of all ages, encouraging a broader appreciation of astronomy and science. Educational outreach programs use Andromeda as a case study to teach fundamental astronomical concepts. Schools, museums, and science centers develop workshops and educational materials based on Andromeda's structure, composition, and evolution. These programs help students and the general public understand key ideas in astrophysics, such as the life cycle of stars, galaxy formation, and the role of dark matter. Additionally, social media and online platforms have become essential tools for sharing discoveries about Andromeda. Astronomy blogs, podcasts, and YouTube channels create content that breaks down complex scientific findings into understandable language. This accessibility allows people worldwide to stay informed about the latest research and developments. Amateur astronomers play a crucial role in public engagement with Andromeda. Through community observatories and astronomy clubs, enthusiasts observe the galaxy, participate in citizen science projects, and share their experiences with others. This hands-on involvement fosters a sense of community and encourages lifelong learning about the cosmos. Educational outreach also extends to formal education settings. Curricula in schools increasingly incorporate current astronomical discoveries, using Andromeda as a context for teaching scientific methods and critical thinking skills. This real-world application of science motivates students and helps them grasp abstract concepts more concretely. The representation of Andromeda in films, literature, and other media platforms highlights its cultural significance and impact on public imagination. In literature, the Andromeda galaxy has been a setting for numerous science fiction stories and novels. Authors often use the galaxy as a setting for exploring themes of exploration, alien life, and the mysteries of the universe. These stories stimulate interest in astronomy and the real scientific phenomena associated with Andromeda. Films and television series have also depicted journeys to Andromeda, encounters with extraterrestrial beings from the galaxy, and the challenges of intergalactic travel. These stories, while fictional, raise questions about humanity's place in the universe and the possibilities of life beyond Earth. By bringing Andromeda to the screen, filmmakers provide a visual and imaginative way for audiences to engage with these cosmic concepts. In the world of video games, Andromeda has served as the setting for adventures and space exploration missions. Players navigate spacecraft, encounter alien species, and uncover the secrets of the galaxy. These interactive experiences allow individuals to explore Andromeda in a way that is immersive and engaging, further fueling interest in real-world astronomy. Documentaries and educational programs offer another avenue for Andromeda's portrayal in popular media. These productions provide factual information about the galaxy, its structure, and its place in the universe. They often feature stunning imagery and expert commentary, making complex astronomical concepts accessible and fascinating to a broad audience. Social media and online platforms have also played a role in bringing Andromeda closer to the public. Astronomy enthusiasts share photos, articles, and discussions about the galaxy, reaching people who might not otherwise engage with scientific content. This democratization of knowledge helps to cultivate a community interested in space and science. However, what does the future hold for missions to the Andromeda galaxy? Although direct space travel to Andromeda remains well beyond current technological capabilities, due to the immense distance separating it from our own Milky Way, future missions are being conceptualized to study our galactic neighbor with unprecedented detail. Advancements in telescope technology are at the forefront of these future missions. Scientists plan to use next-generation space telescopes that will succeed the James Webb Space Telescope. These instruments will have even greater sensitivity and resolution, allowing astronomers to study the individual stars, planetary systems, and other celestial objects within Andromeda with much clearer detail. One of the significant objectives of these future missions is to map Andromeda's full extent, including its halo, disk, bulge, and satellite galaxies. By doing this, astronomers aim to gain a comprehensive understanding of its structure and composition. Such data will help clarify the processes of galaxy formation and evolution, contributing to our overall knowledge of the universe. Another goal is to search for exoplanets within Andromeda. By employing advanced detection techniques and instruments, future missions could identify planets orbiting stars in Andromeda. Studying these planets' atmospheres and conditions could reveal whether any of them might be capable of supporting life, expanding the search for extraterrestrial life beyond the Milky Way. Future missions will aim to study the phenomena of star formation and death. Within Andromeda, scientists hope to learn more about the life cycle of galaxies and the forces that shape them by observing these processes. In terms of direct exploration, while current technology does not allow for a manned or unmanned mission to Andromeda, future advancements may one day make intergalactic probes feasible. These would be designed to travel at a significant fraction of the speed of light, potentially using propulsion methods that are currently theoretical. While such a mission would take many generations to complete, it represents the ultimate dream of human exploration. As we reach further into space, understanding and mitigating humanity's environmental footprint becomes crucial. Space exploration, while advancing our knowledge and technology, poses environmental challenges. The launch of rockets, for instance, emits pollutants into the Earth's atmosphere. Rocket propellants release chemicals like chlorine and alumina, which can harm the ozone layer and contribute to atmospheric pollution. Debris is another significant issue. Space missions leave behind debris, or space junk, ranging from spent rocket stages to broken satellites. This debris orbits the Earth at high speeds, posing collision risks to operational spacecraft and satellites. Efforts to track and remove space debris are ongoing, but the growing number of objects in space makes this a complex environmental challenge. On planetary surfaces, contamination is a concern. Spacecraft visiting other planets or moons can carry Earthborne microbes, risking the contamination of these environments. This is particularly significant in the search for life, as introducing Earth life can complicate the detection of indigenous life forms. Space missions must follow planetary protection guidelines to minimize this risk, ensuring spacecraft are sterilized and missions are carefully planned to avoid biological contamination. Light pollution is an often overlooked consequence of space activities. Satellites and large constellations, like those used for global internet coverage, reflect sunlight back to Earth, interfering with astronomical observations and altering the natural night environment. This affects both wildlife and human circadian rhythms, highlighting the need for responsible satellite management and design. Looking to the future, space exploration may involve extracting resources from asteroids, the Moon, or other planetary bodies. While this could reduce the environmental impact of mining on Earth, it raises questions about the sustainability and ethics of extraterrestrial resource extraction. Developing guidelines and technologies for responsible space mining is crucial to prevent harm to these untouched environments. By developing sustainable practices and technologies, we can minimize the environmental impacts of our journey to the stars, ensuring that space exploration contributes positively to our understanding of the universe without harming our home planet or our neighbors in space.